So, the first unit is relatively easy compared to whatever we have done till now. Okay. So, continuing with that, we are going to start with this topic of standard deviation. And standard deviation is something which you might have come across before also when you actually did your statistical mechanics or a bit of statistics, okay, even in maths. Okay, so we are not going to take much time to finish the topic. Okay, we're just going to do it fast, and we are just going to revise on the formula or the relations that we actually need to solve it. Okay, we're also going to just look into one or two problems, and then we're going to just move ahead. So it basically is a measure of the amount of variation or dispersion of a set of values. So if you are considering a set of value, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then how much it deviates from each other is basically something which we call as the standard deviation. Okay. So what happens is that if the value is low, okay, if we have a low standard deviation, and just write down SD, okay, it indicates that the values, a standard low value would be good for any kind of statistical result because it indicates that the values tends close to mean, okay, so it's very close to mean, and then I think that is okay because we need a result which does not vary that much so that we can say that experimentally this is more accurate. Okay, and if we're considering a high standard deviation, these values actually will spread, okay, over a wider range, so if you remember the other day when we talked about accuracy and precision, there also if a value is very close to the target, okay, we say that the standard deviation is less. On the other hand, if they are far away from the target and also spreading around, okay, they are basically having a high value of standard deviation. Okay, and if we just look into the formula, there are different ways of writing down the formula. We will just take up one or two, okay, and the different ways of deriving it, we are not going to derive them. Okay, so usually standard deviation is denoted by sigma, okay, and it is given as this, okay, and you might have come across this. It is 1 divided by n minus 1, where n is the number of observation that we have. Okay, and then you can basically take a summation, okay, and you can take I is equal to 1 to n depending on how many observations you have. Okay, and then it is nothing but xi minus x bar whole square. Okay, so this is the basic formula that we have. Okay, and having said that, I think we can just take up the terms here. This is number of observation. Okay, so if you're depending on statistical data, you will see that this n might be quite large. Okay, it depends on what values you are doing the calculations for, and x bar, usually whenever you do it, it's mean. Okay, it's always the mean. Okay, and if we take out x1 and then x2 and then you keep on going here, okay, you have got xn. These are nothing but the observed values. These are the observed values that we have. Okay, and one more thing is that this n minus 1 is basically considered as the Bessel's correction. Okay, Bessel's correction. So there are ways of deriving it, and if you do your mathematical physics, you already know what is the Bessel correction and Bessel term. Okay, so basically this is the Bessel correction. So if n is very large, let's say it's 100, 200, even if you don't take this minus 1, still you are going to get a good answer for standard deviation. Okay, so what happens usually is that in some formulas this n minus 1 is ignored and it's just n. So n means we are just taking the total number of observation, just like we do it in mean. Okay, so there is one more term. Okay, this is the standard deviation formula, and then we have got something which we call as the variance. Okay, so if you know the standard deviation, you can easily find out what is the variance. So variance in general is sigma square. Okay, if you know the variance, you can find out what is the standard deviation. Okay, so this is summation xi minus x bar whole square, okay, divided by let's just keep it with the above formula n minus 1. You can just put it n also, okay. So that's the variance that we have, okay. And if you remember, it depends on the frequency also, okay. And frequency means how many observations are there for a particular result, right? So for a particular year, so what we can do is we can probably just take up one numerical, and based on that we can actually just try to understand the standard deviation in just this one slide. Okay, so let's just take up a numerical here. The question might be something like this: the frequency. So the question might be the frequency table, okay, of the monthly salary of 20 people is shown, and then I have to just write down this. So let me write down the salary here, okay, and let me write down maybe the frequency here. So if you do that, you can basically find out what. So what is the question? The question says calculate the mean and standard deviation. Okay, so you have to just find out the mean and the standard deviation using this. So let's just write down the values that are being provided. Okay, okay. Maybe just to make it a bit more legible, I can take a gap here. Okay, yeah, I think that will be easy. Okay, so I'll just take this is a very simple illustration. Okay, as I told that I might give you some question which might be a bit difficult than this, but I think you can do it. Okay, so salary of 3,500 is number of people getting that salary is 5. Okay, and then salary of getting 4,000 number of people is 8. Okay, and then we have got, let's say, 4,200 and the number of people is 5. And then I'll just take one more observation, 4,300, okay, and the number of people is 2. Okay, so this much salary, I don't know how do they survive. I hope it's a part-time job, but the amount is in dollars. Okay, okay, anyway, so we'll just get to the mean part. Okay, we have to find out the mean here, and I think the mean is a very simple concept that you know already. Okay, so whenever you are going to calculate the mean, you're basically saying that, let's say I have got values as 2, 7, 10, 14, and I want to find out the mean. What you do usually is add them up and you divide by the number of observations, so that's 4, and then you can find out whatever is the mean, right? So this is the way that we do it usually. But here, you know how many values are there. There are 3,500 5 values, so that means it's going to be 3,500 plus 3,500 plus 3,500 plus 3,500 plus 3,500 5 times. Okay, so the formula for mean usually changes, okay, because there is a frequency term. So if you just want to do that, we basically do is this. Okay, and I think I don't need to explain this, very simple, xi fi. Okay, so that means you're going to take 3,500 5 times, so you're just going to multiply it with 5. 4,000 8 times, you're going to multiply it with 8. 4,200 5 times, and then 4,300 2 times, and then you are going to add them up, and that is what is the summation is for, right? Divided by the total number of observations. So you see, it's not 1 2 3 4 observations. 3,500, there are 5 observations, so you have to add this up, so the frequency needs to be added up. So I think this is simple and you should not get confused here. Okay, fi, and sometimes they also write it down just as capital N. So capital N is equal to summation fi in this case. Okay, capital N is equal to summation fi in this particular case. Okay, so what you can do is we can probably do it. Okay, and then you will be getting the mean. So it is 3,500 into 5. I'd suggest all of you to please practice. Okay, and then plus. Okay, and then you keep on adding everything, and then finally at the end you will be having 4,300 into 2. So I'm just not putting the other two values, it's trivial, right? Divided by summation fi. So if you just take the summation of this, you can see this 5 plus 5 10 plus 8 18 plus 2 20, right? So it is nothing but summation fi is 20, correct? And this is already written here, 20 people. So if there is a discrepancy here, if some changes, maybe this is wrong or maybe the frequency is wrong. Okay, So you need to check that out. Okay, so that's 20. So if you just do this calculation, you are going to get the value to be 3955. This is so simple that I don't want to actually just give you this for calculation. I think it's okay. And then I want to find out what is the standard deviation, right? So if you just want to find out the standard deviation, I'll just put it up here, sigma. Okay, and then again the same logic here, that you have it here as xi minus x bar whole square, and you are just considering there is xi one value, x1 one value, x2 one value. You are just considering it as x1 1, x2, x3, and there are only one values of each. Okay, but here we have got 5 values of this, 8 values of this, and so on. So what we are going to do is we are going to slightly modify the formula here. Okay, it is going to take up as summation fi xi minus x bar. Please remember, the formula does not change. We have the frequency because it tells you what is the number of observation. Okay, and divided by, let's not take the minus 1 here, because if you're just taking it 20, that depends on what kind of rules you are following, what formula you are following. You can just take up to be minus summation fi. Okay, and then what you can do is this. Okay, so it's the same thing here. So fi is 5. Okay, and then xi, I'll just put one value, representative value. So xi, okay, is nothing but 3500, the first observation. For illustration, I think you understand this. This is x3500, that's xi, minus x bar. X bar we have just found out, 3955 minus 3955, and then you just square it out. So you just square it out. That means whatever value you're going to get is all going to be positive. Okay, there is no question of getting a negative value here. Okay, you're basically going to get the correct standard deviation, and then what you do, you just keep on adding all the 4 values. Okay, 1, 2 and 3. So the remaining 4 values you can do it in a similar way, and divide it by summation fi, that's 20. Okay, so if you do the calculation, your answer should be somewhere around 282. So that's the standard deviation. Okay, so that means if you consider these values, this value and this value, okay, the mean deviation from this particular result is 282. Okay, so if you consider this range, maybe this is not such a high value. Okay, because if someone is getting a salary of 3500 and someone is getting a salary of 4200, on that scale the difference is not much. So standard deviation also says the same. Sometimes what happens is, if you just look into the value and you see that the value is, let's say for this particular case you're getting, let's say, around 3400, something like that, standard deviation, you straight away know that the answer is somewhere wrong. Okay, so the values are not that far. If it is not that far, you cannot say that this will be in thousands. Okay, this will be in hundreds. So this is the standard deviation. So I think this particular slide is helpful to understand standard deviation. Okay, and just maybe just one final note which I can provide. Okay, uh, that's this, that sometimes if there is a range of value, and I think this is something which you have already done. Okay, note, if it's range, so it's like here they have provided the salary to be 3500, but then there might be a range of, let's say, 3000 to 3500. Then you just take the mid value, right? So if it is range, like suppose, let's say 120 to 130. Okay, then the midpoints, okay, the mid points are taken as xi. Okay, xi in this particular case, uh, sorry, so in this particular case, the example 120 to 130, I can just take it to be 125. So in exam, if I'm asking you such question where I'm talking about a range, please make sure that you write down that correctly. Okay, so that's xi. Okay, so that's all about standard deviation, and I think it's not very complicated. Okay, what we're going to do now is we are going to talk about plotting graphs. Okay, so let me take a new page, and then I'll give you some basics on plotting graphs. So plotting graph is very important. Uh, So you always get some tools to actually plot graphs. Okay, so uh, tools to plot. So if you go for any kind of scientific research, most of these graphs are being plotted by a software which is called Origin. So this is a software which you need to learn, and it doesn't take that much of time because all of us are nowadays a bit tech savvy. So learning a software should not be a big problem. I'm sure many of you already know about Photoshop, and also since you know these use of how to actually learn this process, you can easily use Origin. You have the resources, you can use YouTube and check it. Okay, so basically for most of the time you will see that any research purpose, if you are going to plot any kind of graph, it's basically Origin that is being used. Okay, and if you just want to plot it in your system which does not have an origin, it is Excel. Okay, so you can use an Excel sheet to actually also plot the graph. Okay, but then please remember this origin is paid. This is a paid version, but then there are ways of going about it. There are certain online tools to plot the graph. Okay, online tools, for example, you plot it in Google Drive, but then the control is not that good. You don't have that many options of plotting a graph, so it becomes a bit difficult. Okay, even this particular software you can actually plot a graph, but then what happens is you are doing it manually. Okay, so this app that I'm using to actually teach you, you see this, if I use it, I can actually get these kind of grids. Okay, and whenever you are going to plot a graph, you actually need a grid to actually have a line, right? So I can actually do it, but then this is more or less writing with a pen but on the screen. Okay, so this is something like this. So you can just take this to be 1, this one to be 2, and this will be more or less accurate, and then you can more or less plot the graph. But then it becomes a bit difficult to plot the graph just by using software. Okay, which you have to do manually. So origin and all, what happens is it does it on its own. Okay, it does everything on its own. So as a result of which you can just use this origin software. Okay, so that's actually a good tool to plot graphs. But then before you actually really plot a graph, you need to know certain things. Okay, certain basic concepts which are important. Okay, and this is something which you're going to just look into. So you never plot a graph or something which you might have done in your earlier classes. Okay, you need to do it accurately, you need to follow some results and so on. Okay, so I'll just give you some basics which you might already know, but then you might have missed out some points, you never know. Okay, so you basically, whenever you are plotting a graph, you are plotting a graph between x and the y axis. Okay, and you are basically doing it on a 3D diagram. If you use tools like Origin and Excel, you can even plot a 3D graph. Okay, so you can have a third variable involved in the graph, and they all can be represented in the same figure. So whenever you are plotting a graph, the x part will always be the independent value. I don't know if you have learned this or not, but then whenever you are plotting a graph, along the x axis, we are always plotting the independent value. Okay, and along the y axis, we are always plotting the dependent value. Okay, dependent values. Now what do you mean by independent and dependent? So if I want to get current, I have to vary the voltage. So if I change the voltage, the current might increase or decrease. Okay, so if I increase or decrease the voltage, the current might increase or decrease depending on a normal circuit. Okay, so that means based on voltage, current changes. So whenever I'm talking about independent variable, maybe this example I can take to be voltage. So if I change the voltage, I'm going to change the current. So current. So whenever we are actually getting a graph, I have seen this a number of times. Many students are confused what to plot along the x-axis, what to plot along the y-axis. So this is the thumb rule. Okay, this is the thumb rule, and this is important. Okay, so this you should remember whenever you look into an equation. See what depends on what factor. So the factor on which a particular factor depends, and if you want to plot the graph between those two factors, you'd see on what it depends, that will be along the x-axis, and then the other factor will be along the y-axis. Okay, so if you just take this important points, whenever you plot a graph, always you have to use legends. Okay, so legends means that if you are actually basically, let's say, uh, plot sorry okay, let's say you are just plotting a graph. Okay, and then what does this line represent? is something which can be written here. So maybe you can just give a solid line and then you say this represents A. Let's say it's for a material. Let's say I am plotting IV characteristics for copper. So let's say this is for copper, okay. This should be a straight line rather. Okay, maybe it's something else, a semiconductor. And then maybe you can represent another line, okay, and then you can actually say that the dotted line is for the material B, and so on. So this is basically what we call as legends, okay. So this is important, and this usually we do it when we draw a hand-drawn graph. But then from now onwards, even if you're doing your projects and all, plotting of graph probably will be in softwares like Origin, okay. So that's important. Use of units is very important, and I think all of us know it, but then somehow we miss it, okay. Circle the plotted points. I'm just since it's a part of the syllabus, I just don't want to leave anything uh, untaught, okay? Because I want to explain these things because you already know it, and I think it's always better to put it in sequence. And whenever you are basically plotting a graph, thumb rule is at least there should be 6 observation, okay? Observation. A 6 number of observations should be 6 if you are going to plot any standard graph. But sometimes, depending on the experiment, you don't get that many points, and that is not wrong either. It depends on what kind of observation you are doing, okay. But technically there should be around 6 points, okay. And I will give you a very interesting result now. Graphs can be used, okay, to extrapolate, okay, quantities. If there is a value which lies outside the plotted points, you can actually predict that, and that is called extrapolation, okay. Beyond beyond limits of observation. Now in order to prove this point, I will probably just take an example, okay. I'll just probably just take an example, and that example is going to be something which you already know, okay. So let me just talk about something which we call as the Churl's law, okay. Churl's law. So if you just go to your chemistry, okay, we have the term which is called the Churl's law, okay. And Churl's law says that if we just take the ratio between the volume and our temperature, it's going to be something which we should get the constant. So for a gas specifically, if you take volume by temperature, you have it as constant, okay. And then what we do, we actually plot a graph between volume and temperature, okay. So we just take this graph, okay, and then I'll probably extend this part, okay. And then if you just take this, probably you will be getting something like this, okay. Let's say something like this, okay. And then since the volume depends on temperature, so maybe I can take temperature on this axis, okay, and volume on this axis. So you have got a volume versus temperature graph, okay. Now there is a term which we call as absolute zero, okay. If you remember, or maybe I can just type this down, okay. So there is something which we call as absolute zero, okay. So what exactly does absolute zero mean? Okay, what exactly does absolute zero mean? Can anyone tell me what does absolute zero mean? So you might have heard about this term absolute zero. We basically say it's 0 Kelvin, okay? And sometimes it's a very important question
Sir,
even in yeah, yeah, Pragya, tell me.
uh, minus 273 Kelvin maybe.
Didn't get you. It's a bit jittery, the connection. Can you explain absolute zero?
Uh, sir, minus 270 degrees Celsius.
Yeah, that's the value. But what is the meaning of absolute zero? What happens at that temperature? That's the value. Okay, it's to be perfect, it's minus 273.15 degrees centigrade. That's absolutely correct. That is what is we call as 0 Kelvin. Okay, but then the question is, what is the meaning of absolute zero? What happens if a molecule or a system gets to that temperature? Okay, let me tell you some interesting facts here. Okay, let me make it more interesting. Nowadays, Japan is more or less very much advanced in this field. They are working on maglev vehicle. Okay, maglev means mechanical levitation. Okay, so what magnetic levitation? Sorry, not mechanical, magnetic levitation. So those trains which are actually super fast trains are actually not touching the track. They are actually mid-air. Okay, they are floating, but then they are actually being controlled by superconductors. Okay, so superconduction is basically a property at which the resistance drops to zero, and this happens for certain material at a temperature which is below 0 degree centigrade. That means you go to the minus range. Okay, so if you go to certain range, you see that the material will actually behave like superconductors. Okay, and then when we pass current through them, they actually use minimum energy to actually generate a magnetic field, and based on which we are actually having the maglev vehicle. Okay, and Japan is already running those vehicles. In India also we are soon going to have it. Okay, the technology. China also has it. So uh, there is a certain range of temperature up to which we can go till date. Okay, if I'm not wrong, I've not seen the latest article, but we cannot go beyond minus 180 degree centigrade. Okay, but then when we talk about absolute zero, we are talking about a temperature of minus 273.15 degree Kelvin. The question is, how do we know it? Because we didn't even achieve that temperature. Okay, and that is the beauty of knowing the definition of absolute zero. Okay, so before I go to that, probably I can just write down the definition here. Okay, the lowest temperature. Okay, that this is the important word, that is theoretically possible. Okay, theoretically possible. Okay, at which the motion of particles which constitutes the heat. Okay, which constitutes, basically whenever there is any kind of heat being given out by a particle, basically it's nothing but the motion of the particle. It's vibrating, as a result of which it is giving out some energy, and that energy is nothing but heat. Today would be minimum. So technically we can say that the molecule is not vibrating. So even if you go to a temperature of, let's say, minus 5 degree, minus 10 degree, minus 20, minus 30, the particles or the molecules inside the system still has got some kind of motion. Okay, so if you look into the definition of absolute zero, the lowest value that is theoretically possible at which the motion of the particle which constitutes the heat would be minimum. Okay, now the question is that if we are having a vibrating particle, that is basically not going to occupy any kind of space or any kind of volume. Okay, it's basically just going to be there at one particular point.
Sir,
Okay,
sir,
so yeah.
hello, sir. Sir, can you explain
Yeah,
again the last line
tell
at
me.
which the motion of the particles which constitutes heat would be minimum, sir?
Which constitutes heat? I didn't get the complete question. Can you just
Sir,
repeat?
after the comma part, at which the motion.
At which the motion of the particle, okay,
Yes, sir.
which constitutes the heat would be minimum. That means, in simple words, the motion of the particle would be minimum. We do say minimum, okay, because we have not yet gone to that temperature to see if the particle really stops, okay, moving. So 0 on Kelvin scale, okay, okay, or 273, that's minus 0.15 degree centigrade. Okay, so we usually remember 273, we forget this 0.15, but I think we should remember it. Okay, that is how the conversion works. So whenever you are converting degree centigrade to Kelvin, we use this value 273, but take it to be 273.15. Okay, so this is at this particular point. Now if you actually are plotting the graph at, let's say, in 0 degree centigrade, sorry, degree centigrade, what happens here is, now we can actually do this word that I used, extrapolation. Sorry, extrapolation. Okay, this is the word, extrapolate. So what happens here is, what we can do is, let's say we are actually having up to some point, and we know that the volume and temperature are directly proportional to each other. So even if we go back or move forward, we are going to get a straight line. Okay, we are not going to deviate from the nature of a straight line. That's what Charles to predict. So if we just keep on going on a straight line, we are going to intersect the x-axis on the graph at this particular point. Okay, and that particular point is basically nothing but minus 273.15. So this is an interesting fact that using this logic, using Charles' law and using the idea of extrapolation, okay, and whatever idea we have about absolute zero, we are able to predict what is the temperature. So this temperature which is predicted is theoretical. It's not yet achieved that particular temperature. Up to 180 degree it has been achieved. The sole aim of achieving 180 degree minus was actually to get good superconducting behavior. Okay, but then since I'm telling you some stories, I think I should also tell you that the aim is not to get superconductors at lower temperature. The aim is to get the superconductors at near about the room temperature, and it's still a challenge. Okay, someday if you are discovering it, you'll probably get the Nobel Prize. Okay, so this is what is extrapolation is all about. This is the beauty of graph. A graph will tell you and give you a lot of information about a system, okay, even if you don't have all the points getting plotted, okay. And there are different ways of drawing a graph, and there are different kinds of graph, okay. And as you go along with your different kinds of research work or your syllabus, you're going to come across these, okay. So the aim of this particular subject is to provide you just a basic idea, okay. So when you basically write down a straight line graph, okay, we usually write it down as y is equal to mx plus c, okay. And if all of us don't remember it, probably we can just recall this together, okay. We can just have a graph between x and y, okay. And then if you are basically going to have x as 0, y is equal to just c, okay. So using that condition, we know that it does not start from the origin if you're basically considering a straight line graph, okay. And if we just want to know what is the value of c, what we do is we take it this, yeah. So this is the value of c. So this is basically called the intercept, okay, y-intercept. So we have the intercept here, and then when we plot the graph, I think this is very trivial, we already know it, okay. So we're just revising it. I'll suggest all of you to please revise it and remember these rules and what the graph will actually give you, what kind of information it will provide, okay. And m is basically called the slope, so we know it, these things, okay. So what we can do usually is we can actually plot a graph, and then we can actually take this difference and take this difference at any particular point. We are going to get the same slope everywhere, okay. So what happens is, in general, let's say if I'm plotting a graph between voltage and current, okay, and we already know that the formula is V is equal to IR, okay, we can easily plot the graph and find out what is the value of resistance V by I, okay. So you can just take this value, and this should give you I, and you can take this value, this should give you V, okay. Or maybe we can say write down delta I by delta V, okay, depends on what kind of notation you are using, and then that will give you the resistance. So you take it at any particular point, you are going to get the same value of resistance, okay, because this is a graph which behaves very decently, okay. It has got a particular pattern, okay. It's not erratic, okay. It's basically just moving straight, okay. It does not have any other behavior present, okay. If we just take a simple example of, let's say, Boyle's law, okay. mm, Boyle's law. So pressure into volume is equal to K. That's a constant, okay. And based on this, we can say that pressure is equal to K into 1 by volume, okay. Now, what happens is, if you are actually going to want to get a straight line here, okay, you see that this is actually P, which is actually the dependent variable. And I think this is quite logical, because if you take any kind of physical system, you know that the volume will actually depend on the pressure. If the pressure is more, the volume is going to be less, okay. If the pressure is less, the volume is going to be more, okay. It will try to occupy more, so this is independent, right? So this is the independent part. So what we do is we basically sorry, I'm just writing the opposite one, right? Sorry, pressure is the independent part, because pressure is on this side. Whatever value volume takes, based on that we'll get the pressure, okay. I just said the opposite, sorry. This is not V, this is not 1 by V, I'll just write down it as V, okay, the volume, okay. So the volume is dependent, okay. So if you just look into the Boyle's law, I just said the opposite part. What happens is that if you are actually having higher volume system, you know that the pressure is less. If the volume is very less, it's compressed. Okay, we are compressing it. We are knowing that basically the pressure is going to vary. Okay, so it depends on each other. Okay, and then in this case, if you look into the formula, P is the independent one and V is the dependent one. So if you actually want to get a straight line in this particular graph, what we are going to do is, okay, so we are just going to take the dependent value on this side, sorry, independent value on this side. Okay, so that's pressure. Okay, and if we just look into this particular formula, okay, did I mix up something here? Pressure, volume, okay, yeah. Yeah. So actually, whatever example I said is correct only. It looks into the formula that if you take volume, okay, which is actually independent, it will give you pressure. But then in general, what we can say is that pressure is the independent variable, okay. So if you have, let's say, balloon, let's say, or maybe a box whose surfaces can be moved, okay, and if you apply some kind of pressure, you are going to see that the volume will basically change. Okay, so it will decrease in this case because you are applying pressure from all sides. So if you consider this particular condition as per Boyle's law, we can say that the pressure is independent and the volume is more or less dependent factor. Okay, depends on the pressure. So if you take that, what we can do is, if we just want to plot a graph between pressure and volume, and if you want to get a straight line, we are not going to plot a graph between pressure and volume, we are going to plot a graph between pressure and 1 divided by volume, because you know pressure is directly proportional to 1 by V. It is not proportional to V. Okay, so that's why when you plot this kind of graph, then only we can actually expect a straight line. So sometimes what happens is, depending on what kind of problem you are having, and if you are going to plot a straight line and you are going to illustrate that graph, you need to have this particular point clear. Okay, you have to just see that what are the variables which I need to plot along the x-axis and y-axis, based on which actually I can get a straight line. Okay, so just an example, maybe one more example would be, let's say y is proportional to x to the power m. Okay, and I can just simply write it down as y is equal to kx to the power m. Okay, so what is the easier way to plot a graph so that I can get a straight line between a function of y and a function of x? Okay, one way is of course to plot a graph between y and x to the power m. Okay, but then we can also do one more thing. We can actually take log on both sides, and this will give you more information. So if we just take log on both sides, we do have this as log of y is equal to, okay, m log x, we can say this part, and these two are multiplied, so I can just simply say it is log of k. Okay, so if we take this, we can actually plot the graph, and we can just simply write it down as m log of x plus c. So this c will actually represent the intercept, right? So I'm not just showing it in the graph, but I think if we just plot a graph here, log y versus log x, we are going to get a straight line. So it depends. Sometimes you don't really plot a graph between log x and log y. What kind of information you need, depending on that you plot a graph. So you can just plot a graph between y and x. And depending on whether it's a square or a cube or a root, okay, you'll get the value. Okay, so if it's basically a square, let's say you remember this, y square is equal to 4ax. That's the equation of a parabola. So here you know one variable is dependent on the square of the other. So you're going to get a parabolic graph. Here also, if this m value becomes 2, you're going to get the graph as a parabola. Okay, so you know log y versus log x, we are going to give a straight line. So it depends on what is your aim, what kind of graph you need, and depending on that you can actually get it. Okay, so these points are important to keep in mind, okay, whenever you are actually plotting any kind of graph.